We're going to take a look today at Michael's joule thief circuit. Again, this is for experimental purposes only. These are the parts that are in it. This is a NPN transistor, MJL1194G. It goes base collector emitter. This is the correct flow pattern for this. The resistors are resistor 1, 1K. The resistor 2 is 1 meg, or a 1 meg potentiometer. We have right here the point-to-point connection diagram. We also have the theory diagram right here. Let's get into the point-to-point and see exactly how this thing's going to work. So we'll start over here with the power source. It's 15 volts, and I did not write it on there. And adjust the camera, sorry for that. We have channel A and we have channel B. The number 1 is the in, the number 2 is the out. Pretty simple. This right here is just where the wires come together on your Rodin coil to make channel A and make channel B. I drew them in there so that you would not miss them when you had this. Obviously that's the Rodin coil. So let's take a look at the flow direction of this circuit. We go in here into the channel A, goes through your Rodin coil, comes out channel A, comes down to resistor 1, then it goes right over here to the potentiometer, then it goes over here to the transistor on the B, which is the base. Now, the second way the flow goes is it goes in through channel B, goes right here, it goes right over top, it does not connect there, goes in through the out part, goes back into the coil, goes back out this way, and then goes into the light bulb. Now, this also has a direction that goes here. Now, why are there both? There are both on this because it's a switch. As this core saturates, the power will go right over here to the light bulb. As the saturation comes down, it'll go down to the switch. This is the path of least resistance. This is the path that'll take when it has the highest amount of energy, because this transistor is a switch. Now, when it switches over to here and goes in through, now it comes back down through here and takes the negative path through the circuit and back to the power. Pretty simple. That's the way it works. Let's get on to the theory part right here. Same setup, just drawn a little different. You have the power that comes in here, goes in through coil 1, down through the resistor, then back through our potentiometer. Again, a potentiometer is just a resistor that we can change the resistance on so that we can get an approximate value. Once you get it set, you can test it, put in a resistor that matches that value. Again, flow pattern goes into here. That goes in through the base. Now, the secondary power comes in through here. This does not go through this coil. It just connects off of the wire here, comes down, back through this one, and then off to this. Again, we have our switching going on. So we have our neon bulb here. As the core saturates through both of these, it goes down this way and lights up the neon. Now, when it doesn't and it's non-saturated, it goes back here through the path of least resistance and comes back through your circuit to your negative. So, coil direction matters. That's why they put it this way. Everything is continuous from A to B, A to B on both of them as you identify the wires in your Rodin coil. So what happens? One magnetic field, secondary magnetic field, creates a massive magnetic field inside of it. Then the switching that goes on will turn it on and off, just like that. Now you're going to get power through your Rodin coil. This is why this is an effective circuit. Hopefully in this short diagram, it'll give you the description for it, tell you the parts to it, the directional flow, and then you can build this circuit and run your Rodin coil as well. I hope this helps everybody out. Thank you.